So in this module, we'll first take a look at how we can send text messages from the client to the server. And then in a later part of the module, we'll take a look at how we can send binary messages. We'll also take a look at the two ways we can handle messages, whole messages and partial messages. Partial messages become important when we're handling binary messages, as the size of the message can be so large. So as we are writing a chat application, we'll add a chat endpoint. And this is simply a new Java class called chat endpoint. And we know that this class needs to be annotated to make it a server endpoint. So we'll add the server endpoint annotation to this. The server endpoint annotation, we need to specify the URL of this endpoint. So that will be /websocket/chat. We then have choices as to how we implement the endpoint. We could go ahead here and implement the message handler interface, message handler.whole in this case, for a string. And that makes this server endpoint both an endpoint and a message handler. And that's a fairly standard practice when we write Java WebSockets. However, we won't implement the interface directly. Instead, what we'll do is we'll use the annotations to add message handlers to this class. And we'll add a text handler in this part of the module, and then later we'll add a binary handler to show that we can add both text and binary handlers to the same endpoint, and also to show that we can use whole and partial handlers within the same endpoint. So for this, before we implement the message handler, we'll add an open method. So we'll have a public void onOpen, and this will allow us to handle socket opens, and this will be annotated with an onOpen annotation to say that this is our open method. The open method, if you remember, is passed a session, which we will make use of, and an endpoint config, which we won't. So I'll simply name the variable underscore here to show that we're not going to use it, and then use resharper to bring in a reference to the session that we're going to use. In the endpoint, we'll define a session member variable, so we can hold on to the session, as we'll be using it later. And then in the onOpen, we'll have this dot session equals session. We also need to keep a collection of all the connected clients so that we can send messages to all of those clients. When the client opens a connection, this endpoint class, this chat endpoint class, will represent that open client. So we need to maintain a collection of these chat endpoint classes, one for each open client. And that will be held in a static collection. So again, within chat endpoint, we can have static, and the collection we have will be a list of chat endpoint instances. We'll call this clients, and we'll set this equal to a new copy on write array list of chat endpoint. Copy on write array list is useful when we have many reads from a list but few writes. It's a thread safe list. So finally, inside onOpen, we need to add our current chat endpoint to that collection. So we do clients.add this. Now that we have onOpen, we'll add an onClose handler, which again will be public void onClose. Close also takes a session, and it also takes a close reason parameter. We haven't used close reason before. In this case, we'll just print out the reason that the socket's been closed. It helps us with any errors we might get when we're trying to use the socket. So we'll simply print out reason.getReason phrase. And we also need to remove ourselves from the list if we have been closed. So clients.remove this will simply take this message listener out of the list of listeners held in the client list. Now that we have open and close in place, we can add an on message handler. And the on message handler will be public void. We'll call this on message. And this simply takes the type of the message, which in this case will be a string message. And we'll call this message. Then from inside the on message handler, we'll broadcast that message. So we'll add a helper function called broadcast, and we'll simply pass that the message. We might use this broadcast function in multiple places. So we can add the broadcast function to the code. Then inside the broadcast function, we'll iterate over each client in the list. So for every chat endpoint client, in clients, and we'll do something with that client. And what we'll do is simply send out the same message that we received. So we'll broadcast the same message to all the listening clients. So we need to take that client, find its session reference, which we saved away inside on open, get its basic remote, and then on basic remote called send text, sending out the message. Now we can't do that directly, as the send text method is going to throw an exception. So we can surround that with the try catch, and then inside the try catch, if there's an exception, we'll remove ourselves from the list. So again, we'll do clients.remove this, and then we'll also close our WebSocket session. So again, we do client.session.close, and again, this will throw an exception, so we'll add a try catch. But in this case, we'll do nothing. There's not much we can do to recover from this. Maybe just put a comment here, or maybe log away the fact that there's been an exception. In this case, I'll add a comment saying do nothing. So once we have the code in place, we can run the application. I'll set some breakpoints here so we can see what's happening. I'll go to the run option and select debug. We can restart the server. So this will run the server and start an instance of the client. The browser will pop up. Once the browser starts, it opens a connection to the server, and we can see that we hit the on open handler. In here we have a session. In this case it's a Tomcat session, but it's actually derived from the standard Java WebSocket session. So we're saving away a reference to that inside sessions, and then adding a reference to ourselves to this client. So if I just leave this run, the client, as part of its startup, sends a message. So we immediately hit the broadcast method here from inside on message. For now, we'll just leave that run. We'll come back to that in a moment. If I go back to the client, and then inside the client, enter a name and click on join, this also sends a message to the server. So again, I'm inside broadcast. Broadcast has been called from on message. And here, if we take a look at the message coming in is actually a JSON message. So the client that we have currently is fully complete. So we are writing the server to catch up with the client. So the client is sending JSON messages. We just aren't processing them that way at the moment. Inside here, if I leave this code run, this broadcasts that message to all listening clients. Back in Chrome, if I bring up the dev tools and look in the console, this is the broadcast message. If I close that, make Chrome a little smaller, and run Firefox, send Firefox off to the same address that Chrome is listening on, which is our localhost address, and connect to the server. Again, we've joined from Firefox, and again, as we run this, we'll hit the broadcast endpoint. So leave both of those run. If I go to Chrome and bring up the console and clear that so we can see what's going to happen. So inside Firefox, I type a name and click on join. We'll hit the breakpoints inside IDEA, leave this code run. We create a session, we broadcast the message, and sure enough, that message now appears inside Chrome. So we are broadcasting messages from one browser to the other. At the moment, we're not doing much processing of those messages, but the messages are being sent. So we see we can handle messages just by adding an onMessage annotated handler to our Java server code. This handler works on the signature of the method. So here, the signature says string message. There's no extra parameters here, so it knows that the onMessage handler is a whole message handler for string-based messages. In the next part of this module, we'll add a partial handler for binary messages, and we can do that now.